Greetings, students. So here we're just going to show you some information that you're going to need. We're going to do the review information first for phase changes or changes in state. So the beginning information you need to know that solids, they have strong attractive forces between the particles. So it's kind of like magnets, that the little particles want to be near to each other. And solids, you guys know that they're a lot closer together in a solid. So they stay together. With that, they also have definite shape and volume. If you didn't remember, definite means not changing. So the shape and volume do not change. Also, the particle movement is minimal. Typically, those particles are just vibrating. You can't really see that. Let me show you a simulation of what this looks like. So here we can see our solids. The shape right here, we can see this nice little cube. Right? And the volume, we could measure, 1 centimeter, 1 centimeter, 1 centimeter, we could see that. So we have those different things. Also, you can see the vibrations. You're not going to see it on the outside, but if you zoomed in, those particles really are vibrating. So there always is going to be some particle movement. So now this is showing us the definite state, definite shape, nature of a solid. Inside of this glass, it was the cube, and it's still the same cube. It's the same size, and it is the same shape. So that's that one. Okay? Let's look at a liquid. Okay? Here we can see that the liquid, the particle motion is a little bit more. So we definitely have some more motion here. And let's see what happens when we pour it out. Right? Again, as a refresher, if you notice, the shape is changing. So this is indefinite or a changing shape. The volume, it's still the exact same amount of water, but this is really important that you know those basic ideas for a liquid. And that's what these next couple are. So here, liquids, there's some attractive forces between the molecules, so they still kind of hold together, and that's why you have a definite volume. They don't completely spread out. They have an indefinite shape. This is where they don't hold together enough. They kind of flow, but they kind of stay together. So that's the reason of those particles are attracted to each other. And again, as you saw, there is some particle movement. Also, those particles are moving over each other, so that's why you can see that flow there. Moving on to gases. Gases have extremely minimal attractive forces, so that's why they have indefinite shape and volume, and they completely spread out when we have those issues. So we can look again at this simulation. Let's take a look at the gas. There's not much attraction between these, so they're just going all over the place. Okay? If we change the container, let's see what happens to the shape. So right now they're shaped of a glass, and then the shape goes out to the room. Okay, also way more volume as well. So they are changing shape and volume, how much space they take up. Again, you saw that lots of particle movement. The last piece of review that you'll need to be able to look at and we'll talk about are physical and chemical changes. Physical change, you can change the size, shape, and state of the matter, and you can also go back. So that's essentially what we saw. We were pouring those into different containers. That's just a physical change. Maybe we just changed the shape that was happening there. To make it go back, you pour it in the other container. They're not always reversible, but usually. Chemical change, you're getting a new substance, not reversible. So cooking is typically that. You get something new. That's why it has unique flavors when you do those. So those are some things there. Okay. The last things that we'll look for when we do these changes of state or from solid liquid to gas. Again, you saw that. Changing solid liquid to gas, even reversible, which we'll see in this next video. Evidence of chemical change. I like to say these are all unexpected. Now, you always have to say, that's interesting. That's not what I expected. If you mix hot water with an ice cube, you're going to get a change in the heat of the ice cube, but that's expected that the ice cube would do that. If you mix two freezing cold liquids together and all of a sudden they get crazy hot, that's unexpected. I didn't expect that. That is evidence of a chemical change. So all of these things have to be unexpected. So that's the review material. You need to make sure you're confident with that And then now we're going to apply that more to changes in state.